Hello, today we are looking at combining like terms. We're going to see this quite a bit in algebra, so you really need to make sure that you know what you are doing when you are encountering a situation like this. So for example, let's take a look at adding. You'll see that something like this quite often. You've got 7x, and then you're combining 2x. What does this equal? Well, really what you've got here, if you think of it in terms of this hand, you've got 7x's. Over on the left side of this expression, on the right, you've got 2x's. Count up, you're adding them together, so you're putting them together. You've got 7 over here. You've got another 2 over here. 7 plus 2 would give you 9. And 9 what? Well, 9 x's, 9 x items. That's multiplication is often used for counting like that. And it makes sense if we were to plug in for that x. So let's say instead of x, let's say x equals 6. This is just a variable, this is just a placeholder. The x is just a way to mark where something should be. So let's put in a 6. If this is true, if we did this correctly, then this is going to work and it will make sense. So, I don't know why I wrote 12. Maybe because I like the number, I'm thinking ahead of myself. That's probably it. Should equal 7 times 6 plus 2 times 6 should equal 9 times 6, if what we said above is correct. 7 times 6 is what? Yeah. And 2 times 6, well, that's 12. 9 times 6 is 54. 42 plus 12 equals 54. That checks, that works, therefore it holds true. Anytime that you have any confusion and you're not sure if you did it right, take a moment and plug something in. We could even have plugged in 1, and we would get 7 times 1, I'm going back up to the top here, plus 2 times 1 equals 9 times 1. 1 times anything is itself, due to the identity property of multiplication. 7 plus 2 equals 9, that makes sense. That works, okay? Subtraction is going to be very similar. So I can have, if I have 5a minus 3a, so basically I've got 5 a's and I'm subtracting 3a, so I'm taking out 3 of these a's, and that's it. I'm left with 2a. 5 times 3, or excuse me, 5 minus 3 equals 2. I've got 5 a's, I lose 3. I've got 2 a's left. Again, we can plug in. This time, let's use 4. So if I substitute 4 for a, the variable, 5 times 4 would be 20, minus 3 times 4, 12, equals 2 times 4, 8. 20 minus 12 is indeed 8. That makes sense. Once again, it works. Side note, I can use this is just another variable. It doesn't have to be x, it could be y, it could be g, it could be k. If you really wanted to, you could even make it like a little smiley face, that could be a variable. Smiley face could be a variable. A bit of a time-consuming variable to write and not as easy to say as like a, but it still could be a variable. I do want to give you a warning. Sometimes you will see something like this. The distributive property is what we should be thinking of when we see this, where this would distribute to both of these values on the inside here. But sometimes what I see students do is think, oh, I've got an a here, I've got 2a here, so a times 2a is equal to 3a. That's what that is. No, 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 no. I'm going to draw a big red through that. I'm going to do a frowny face right here, and then I'm going to add like it's crying a river, because it should never do this. It's a mistake. It's okay. We learn from mistakes, but This is just to reinforce the idea that, you know, this is not the way to do it. If you're adding and subtracting, we can do what we did earlier. But in this case, because we are multiplying right there, if you have a times 2a, that is actually going to be the a times a times a. I'm going to focus on this part. We'll worry about the 2 in a moment. A times a is equal to a squared. Okay, and then the 2 is going to be multiplied by that. Really what we've got here is 2 times a times a. I'm just changing the order of what we're multiplying, and a times a is a squared. So 2 times a squared. It is not adding them together because we're multiplying the variables here. So if I, again, were to test this out, and please test it out, if you're not sure if what you did worked, you can just plug in a number and it should work fine. It's a wonderful practice to get into. Let's say that my value for a in this case would be, let's say it's 3, okay? So 2 times 3, to copy actually what this is up here, I'm even going to say it's 3 times 2 times 3. I'm going to change the order. 2 times 3 times 3, and we said this was the same thing as 2 times 3 squared, and 3 squared is 9, so 2 times 9, and that's 18. Compare that to if this was 3 times a, which we said it could be from up there. 3 times a would be 3 times 3, which would be 9. That would not work. We would be sad. If we were to look at the whole expression again here, a times 2a plus 4, we're going to distribute this out. First, 2a times the a there, this would become 2a squared. Then I distribute to the 4 plus 4a. Another rule that we need to follow is if the exponents don't match, we cannot combine them. So we cannot, I'm going to draw a big red X there ahead a time just to be very clear. We cannot say this is like 6a square or 6a or something else like that. This is the most we can reduce it to right there. Really 4a, this a is really the same thing as a to the first. And if this guy up top, if the exponent does not match, then you can't mix. No match, cannot mix, cannot combine. Okay, so this right here, this 2a squared plus 4a, this is simplified. That we can't get it any simpler than this because we cannot combine things that have different exponents for the variables. All right, just a few things to think about here. Why don't you try doing something like this? Let's say 8k plus 7k minus 4k. How could we simplify that? What would we get? There's number 1 for you. And let's test one more here too. Let's say you've got 3x times the quantity 5x minus 2. Okay, test those out, see what you get so that you can compare those with your classmates and talk about them and all that fun stuff. All right, thank you for watching. I hope this was helpful. Look forward to hearing your questions. Have a great day.